Alright, so 26 says, describe the possible real zeros of each function as f of x is equal to negative 2x to the third power, negative 3x squared, plus 4x plus 7. And it says, describe the possible real zeros, meaning it wants you to describe to me out of these possible, how many zeros is this going to have? 3. So out of these 3 zeros, how many could be positive, how many could be negative? All right. So which rule do we have that helps us figure out the number of positive or negative real zeros? Rule of science. Descartes rule of science. Yeah. Descartes rule of science. So what we have to do first, we want to figure out the positive zeros. The way we figure out the positive zeros is we look at f of positive x. We count the number of sign changes between the coefficients. No sign change, one sign change, no sign change. So what that tells me, for a fact, is that there is one positive real zero. So I know this graph across the x-axis one time on the positive side. Alright. Not more, not less. Because I can't subtract 2 from 1 and remain with a positive number. Now, figure out the negative real zeros. I have to first of all find f of negative x. So, the shortcut there is if the degree is odd, it changes sign. 2x cubed. This is an even degree, so it stays the same. Odd degree, so it changes. We subtract 4x instead. And then plus 7 doesn't change. So, one sign change. No sign change. 2 sign change. So that tells me that there's 2 positive real zeros, 2 negative real zeros, or it could be 0 negative real zeros. Now, it says describe, word by word, word for word, it says describe the possible zeros of each function. All right. Easiest way to describe that is to create a table. You have positive zeros, negative zeros, and imaginary zeros. Okay. I know for a fact there has to be one positive zero. Okay, so one positive zero, okay, now there's 2 negative zeros. That's 3 total, that means there's 0 imaginary. But also have an option of having, or a possibility of having 0 negative zeros. So 1, 0, that means the possibility of there being 2 imaginary zeros. And I've now described the nature of those real zeros. Yes. Questions about that? Nope. Now, for those of us that did the problems, 32 and 34, how are those? Pretty good. Yeah, how about you? Let me ask, would it be useful if I gave you like printouts of the answers so you can check the answers? Like not the work or anything, just like the answer. Yeah, see if you find the answers. Because right now, none of us have any idea. The none of you guys don't have any idea. 30 cents before. Right. So you feel confident that it's like, did y'all really have it? You don't know. So you feel confident. So let's look at 34. All right. And what I'll do is I will start on that app, since we all have access to the app, right?
Yeah.
On the app, what I'm gonna do is I'm going to get the answers on my computer, screenshot it. I'm gonna post the answers on there. This is like a viewable document for you guys to look at, so you can compare your answers. And that way check the answers. All right. So we'll look at 34 real quick. 34 is one of the problems towards that was like what like the problem did in the class where instead of me giving you the polynomial, saying find the zeros, I had to go backwards and you found the zero, or you were given the zeros and you had to find the polynomial, or find a polynomial. So it said this function, whatever it is, has the zeros x equals -5. X equals 3, and x equals 4 plus I. Alright? So, let's think about this. It says, write a polynomial function of least degree with real coefficients in standard form that has the given zeros. Standard form means that we want it all the way expanded. Okay? So that's number one. Number two, can someone tell me what degree polynomial this function would be? Why would it be 4 beyond? So you have to remember, we talked about, mentioned this on Friday, complex zeros or imaginary zeros come in pairs. All right. So you have x equals 4 plus I, and you have x equals 4 plus I, but you also have x equals 4 minus I. Okay. Now, one thing you may want to write down, all right, this, so 4 plus I and 4 minus I, these are called conjugates of each other. All right. The nice thing about those is when you multiply them together, the i's go away, and you're left with just a nice real number. All right. Nope. So what we know here is we know that these are our 4 zeros, so this is a 4th degree polynomial. So what we know is that each of these zeros can be written as factors. Okay? How can we get those factors? Well, we have them written like this. So what you do is you say, okay, my factors get set, in order to find my zeros, I have to set my factors equal to 0. So now what I have to do is I have to make these zeros, I have to get everything so it says equals to 0. So I'm going to add 5 here. Add 5. So I have x plus 5 equals 0. That's one of my factors. X plus 5 is one of my factors. Right? That's a factor. Next, I have a 3. I have to subtract 3 from both sides. X minus 3 is equal to 0. X minus 3 is now one of my factors. Okay? Now here, I have a positive 4 and a positive I. So I'm going to subtract 4 and I'm going to subtract I from both sides. What I get is x minus 4 minus I equals 0. All right. This is one of my factors. Okay. Finally, I have a positive 4 and a negative I, so I'm going to subtract 4, add I, minus 4, add I, and x minus 4 plus I equals 0. That is my final factor. So I have those 4 factors. I have 4 factors because I have 4 zeros. That tells me it's a 4th degree polynomial. So what I now know is that my factors, if I multiply each of these 4 factors by each other, multiply them all out, that's going to give me my polynomial. So I know that f of x is equal to x plus 5 times x minus 3 times x minus 4 minus I times x minus 4 plus I. Okay, I know that. Now, at this point, all this is just now algebra. Just distributive property for the next couple minutes. Alright? So, what I'm going to do is I am always going to multiply my conjugates together. If I have five conjugates, I'm multiplying them together. If I have more than one pair of conjugates, I'm multiplying this pair and I'm multiplying that pair together. Because it gets rid of the odds. Okay. If you have 4, you multiply 2 by 4. Yeah. Hello? Yeah, what time? Have a fire drill. Shortly. So, you're going to shut up and walk outside and stand right next to each other up here. Right, I'm going to take one of it. You can run that correctly. I'll get yelling at them. Oh, yeah, where's he going right now? Alright, so again, yes, if I had x plus 2 minus I and x plus 2 plus I over here, I'd multiply those two together, and these. So what do I do here? I'm gonna multiply these first. Alright. So I'm gonna have x times x, that's gonna be x squared. Okay. I'm gonna have x times negative 3. That's negative 3x. 5 times x, that's 5x. So I have 5x and negative 3x, that leaves me over with 2x. Plus 2x. 5 times negative 3 is negative 15. I've covered it there. Alright? Now, I'll multiply this one. I'm gonna multiply this x by everything over here, then this 4 by this negative 4 by everything over here, and this I by everything over here. Okay? X times x is x squared. X times negative 4 is negative 4x. X times I is going to be positive ix. Okay? Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. Negative 4 times I is going to be negative 4i. Right? Negative I times x is negative ix. Right? Negative I times negative 4 is going to be positive 4i. Finally, negative I times I is going to be positive 1. How do we know that? We know I squared is equal to negative 1. Alright? And since it's a negative I squared, then the negative negative 1 is equal to positive 1. That makes sense? So you have a plus 1 up here. Alright. So I'm left over with, I still have my x squared plus 2x minus 15 times x squared. Alright. Negative 4x and negative 4x is going to be minus 8x. Right? 16 and 1 is going to be 17. And what I find is ix cancels out with minus ix. Minus 4i cancels out with positive 4i. Alright. So here's a way to remember a shortcut. Okay. It's always going to be, I don't want to say always, but it's just, so if you see where it's like x minus 4 minus I and x minus 4 plus I, so when you multiply conjugates like this, right, it is always going to be x times x. It's going to be whatever this is, multiply that by, so this is only if like it's x, like they have to get them out here, change it, then multiply this by 2, and then multiply, then square that and add 1.
Oh, really? Alright, that's it. Okay, I see. You got this to x.
That always works in the next day?
Yeah, okay.
If it is of this form,
Okay.
which it typically will be.
I'm not putting it up until we got the I.
Well, that's a shortcut right here. The nice about conjugates, you don't even need to know. Like, the nice about conjugates, you don't have to worry about I. They all go away. The only I you have to worry about is the negative I times I,
Yeah.
which is always going to be positive.
Alright.
Yeah.
Oh, that's pretty cool.
In fact, you're never going to get, I don't believe you're going to get anything that's not minus I. Alright. So here, okay, we're going to x squared, I'm going to multiply this x squared by all three of these and this by that. So x squared times x squared is x to the 4. X squared times negative 8x is minus 8x cubed. X squared times 17 is positive 17x squared. 2x times x squared is positive 2x cubed. 2x times negative 8x is minus 16x squared. 2x times 17 is positive 34x. And negative 15 times x squared is minus 15x squared. Negative 15 times negative 8x is something with 0, 4, 12, 120, 20x. And negative 15 times 17, 15 times 15 is 225. Plus another 30, negative 255. Alright. So I just combine those. X to the 4. Negative 8x cubed plus 2x cubed is going to be minus 6x cubed. 17x squared minus 16x squared, that is 1x squared. Minus 15x squared, that would be minus 14x squared. And then 34x minus 120x, that's going to be negative 86x, I believe. And negative 2 minus 2.5. Assuming I did all that mental math correctly, you know, another notice I didn't say here or there, but that polynomial, in all did you get that?
X times plus 1, what did we do before that?
Alright, so I see, so let's see, my negative 120 came from, yeah, that'd be right. That'd be positive 120. Alright, so that'd be 154, yeah. Alright. Everything else looking good? Alright. Yeah, that's just negative 15 times negative 8 should be positive 120. That's the easy part.
I didn't know. Yeah, you can do it conjugate, right? This is more than a
Questions about that? Okay. So, my next question would be, here's the thing. Our goal for this part of the chapter, this part of the unit, is we want you to be able to look at a polynomial, figure out what are the zeros, what could the zeros potentially be, and also go backwards. We know the zeros. What could this polynomial be? All right. So you want to go to analyze a function. You want me to tell me that function has 7 zeros. All right. And then you want to go tell me out of those 7 zeros, how many will be positive? how many could be negative? Yes.
I understand that part, but it's like, the main part of the machine is being distributed, like,
Well, that's a good problem to have because that means that you understand this stuff is just fundamental stuff. Is what you said. I'd rather you be struggling with the surety of property and understanding this new stuff than being really good at the surety of property and not understanding it. Because if you did all this, got to this part, and then messed up here, you probably lose 1 point on a 6-point question. 5 out of 6, not bad. Like if all your work's right, and then it's like one small mistake that messed up your answer, I'm not gonna take off. Like, not gonna like.
I'm not sure me when you take it off.
Yeah,
I gave him that time.
All right. So let's look at this problem. And I need, you guys got to tell me if you guys think you need more practice on this. And I do have more practice on this. All right. Let's see something else here. Yeah. Alright, you guys have this written down. Alright, so it says write k of x as the product of linear and irreducible quadratic factors. All irreducible quadratic factors means is get down to the point where you have linear factor, linear factor, linear factor, then some quadratic that can't be factored. Alright? So, because if we get down to a quadratic function that can't be factored, that means that there's a good chance that it's going to have imaginary zeros. Alright? So, walk with me here. Alright? What would be the, if I'm trying to figure out, I'm trying to write this down as, like, I need to find the zeros, I need to write these down as linear factors. What would be the first thing that you guys want to do? Hey, I'll just look at the exponent. How many zeros does this polynomial have? Has 5. Alright? We know for a fact that it has 5 zeros. We don't know if they're real. We don't know if they're positive yet. We don't know if they're negative. So, okay, first thing, let's look at sign change. We can do this in whatever order you want. Sign change is a good place to start. So we can say k of x. Look at the discard, we're using the discard rule of signs. It says x to the fifth minus 18x cubed plus 30x squared minus 19x plus 30. Okay, so there is 1 sign change, 2 sign changes, 3 sign changes, 4 sign changes. So what that tells me is there are 4 positive real zeros, or there could be 4 positive real zeros, there could be 2 positive real zeros, there could be 0 positive real zeros. I'm subtracting 2. Alright. So that gets a little tricky. Okay. Now, what does that tell us? That, I'm willing to bet that there is most definitely at least one negative. I'm willing to bet there's most definitely at least one sign change in this next one. Now we go to A of negative x. That's going to be. Now it's x to the fifth, so that sign is going to do what? Change or stay the same? Change. So negative x to the fifth. And this is a odd degree, so it's going to go positive 18x cubed. That's going to say 30x squared. That's going to go 19x. It's going to be 30. Change. So 1. No more sign changes. Alright, so that tells you that there's 1 negative 0, 0. I know that for a fact. Okay? Okay, good. So I've figured out. Alright, and then we need to make this table real quick. You know, plus, minus, imaginary. So we can have 4, 2, 0. Definitely have 1 negative. And that'd be 0, and be 2, 4. Alright? Now, what's the next thing that we would want to do?
We gotta, no, like, group them up.
We need to group them up. No, I don't want to do that. What's another rule that we have?
You guys are here. Shut up, man.
Find what? Rational zeros.
Yeah, rational zero.
Yeah, rational zero theorem. So, that means that I need to find the factors of what? Constant and the leading coefficient. So, do the factors of 30 first, because the leading coefficient is 1, so that's a nice easy one. Alright, so you have plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. Alright. Now, my leading coefficient is 1, so I'm not going to write that. I know that, well, plus minus 1. Alright. Now, I'm not going to write P divided by Q. Because P divided by Q, in this case, is just going to be 1. It's going to be the same thing, because it's going to be 1 divided by 1, 2 divided by 1, 3 divided by 1. It's just going to be all these divided by 1, which is the same thing. Right? Now, okay, I'm at the point now where I'm going to start doing some type of division. I want to figure out what the zeros are.
Yeah.
Rational zero theorem. Now, here's my question. So I want to start with positive, or do I want to start with negative zero theorems? Why do I want to start with negative? Huh?
There's only one negative.
I know for a fact it's definitely negative. If I do positive numbers, there's a possibility that I could do all of those and never find a zero. Don't do it. Alright? So, let's start with, I like to start with negative 1, guess. Alright? So, I'm going to do this. Alright, so we have, I'm going to start with negative 1. Okay, and that is going to be, I'm going to use my exponent, or my leading coefficient 1, 0, negative 18, 30, negative 19,
Negative 4.
30.
Yeah, you just put a 0 there.
Alright? So, we're making 1 down. Okay. Negative 1, 1, that's a negative 1, negative 1. 1, negative 17, negative 17, that's gonna be 13, negative 13, that's gonna be, what's that? 19, 20, 132, negative 32.
Right.
Yeah, mistake?
Yeah.
Where?
Negative 17 times negative 1.
What?
You see where you have negative 7, negative 1 times negative.
Positive 17. Alright, so that'd be 47.
47, that changes the whole game.
Does.
Good job, Lucas.
Thank you.
Okay.
47,
Extra.
negative 47. So that's gonna be,
I gotta give him to it, 6. Ah, you jerk,
Hey,
you gotta
66.
prove me.
66, 96. Negative 1, not a 0. Unless you guys see those mistakes.
But we were sure, there was no one.
No, you are, got positive, a whole bunch of more negatives on the check.
Oh, yeah.
So,
That's a get bothered.
Punch too much.
negative 2, 1,
Uh,
0, negative 18, 30, negative 19, 30.
you have to give me the score.
Bring the 1 down, negative 2, negative 2, positive 4. Alright, that's going to be negative 14. That's going to be 28. 58. That's going to be negative 106. No, 116. That's not going to work. I'm going to go with that. Yeah, so here's what we're going to do. We're going to pull here. We're going to do something a little bit more intelligent. Look at the graph. Because no one feels like sitting here for the next 5 years and you know a fire drill is coming up. You never know what's going to happen in that fire drill.
That was a warm one, that's for sure.
Alright, so we have x to the 5th minus 18x cubed plus 30x squared minus 19x plus 30. And bracket. Alright. I see negative 5.
All this is
Back focus, refocus. Yep. Now again, I have no issue with us using our calculators here to figure out where to sort of start. Alright. So, yeah, we see negative 5 is a potential 0. Right? Looks like it, so let's check that. So we're going to have 1, 0, negative 18. Someone have their calculator ready for any multiplication. Add on to the blue in my head.
You can do it.
Alright.
You got it.
When it's down 1, that's going to be negative 5. That's going to be negative 5. That's going to be 25. That's going to be 7. That's going to be negative 35. That's going to be negative 5. That's going to be 25. That's going to be 6. That's going to be negative 4.
No. You okay with it?
I did it. It's not bad.
You're talking about, that's good math right there.
Yeah.
Oh, that was wrong.
No, nothing like.
Alright, 5 times 5 is 25.
Okay, that's 7. Alright,
So you guys, you guys shouldn't be telling me to do math in my head because I do it good with these fast numbers.
Can you erase and read the other text?
So, I'll bring the 1 down. Bring the 1 down. Negative 5 times, guys. Negative 5 times.
All students should be in the fourth period class. All students should have returned to the fourth period class. No hall passes, remainder of the day. Again, no hall passes, remainder of the day. Thank you.
0 plus negative 5 is negative 5. Negative 5 times negative 5 is 25.
Zero.
So then we have, 25 there, that negative 18 plus 25 is 7. Negative 5 times 7 is negative 35. 30 plus negative 35 is negative 5. Negative 5 times negative 5 is 25. Negative 19 plus 25 is 6. Negative 5 times 6 is negative 30. 30 plus negative 30 is 0. And that shows us that negative 5 is in fact a 0.
Right.
So, over here, let's start by, we're going to start slowly writing this as a product of linear factors. Okay? So, we know that k of x is equal to x plus 5 times x to the fourth minus 5x to the third plus 7x squared minus 5x plus 6.
We're getting work for negative x plus 5.
Because negative 5 is a 0, so I know that x equals negative 5 is a 0. Add 5 to both sides.
Oh, okay, that, all right.
X plus 5 equals 0. I did skip that. Alright? Now, go back and look at the graph. Looks like 2 and 3 might be zeros. 2 and 3 might be zeros. So we're going to check 2 and 3. Okay. So I'm going to put 2 in here. 1, negative 5, 7, negative 5, 6. Okay? Bring the 1 down. 2 times 1 is 2, negative 3. Negative 2 times negative 3 is negative 6. 7 plus negative 6 is 1. 2 times 2 is, or 2 times 1 is 2. Negative 5 times 2 is negative 3. 2 times negative 3 is negative 6. 0. Okay, so that tells you that x equals 2 is a 0. So, x equals 2. Subtract 2 to both sides. My factor is x minus 2, which equals 0. Okay, so I now know that k of x is equal to x plus 5 times x minus 2 times 1x cubed minus 3x squared minus x, so plus x, minus 3. Alright, what do we say the other one was 3? Okay, so we can look at the graph and saw that 3 may be a 0. Okay, 3. 1, negative 3, 1, negative 3. Bring the 1 down. 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. 1 times 0, or 1 plus 0 is 1. 3 times 1 is 3. 0. So that tells you that x equals 3 is a 0. X equals 3. Subtract 3 from both sides. X minus 3 equals 0. So my factor is x minus 3. So, I have x plus 5 times x minus 2 times x minus 3 times x squared plus 1. Okay? So, now I know this right here, all this right here should be up here really. Right? We've written this as a product of linear factors and irreducible quadratics. Meaning we can't factor x squared plus 1. Alright? Now, that means we still want to write this as a linear, as all linear terms. We still want to write this as all linear factors. Okay? Now, let's think about this here. Okay? Right now, we found 2 real zeros that were positive. 1 real 0 that was negative. And at this point, there could be 2 more positives, or there could be 2 imaginary. Look at the graph. It doesn't look like there's any more positives. Alright? So that tells us that there's 2 imaginaries. Now, how can we confirm that? Well, we can confirm that by taking a look at what we have now. We just find all the zeros. If we were given this, find the zeros. We would set x plus 5 equal to 0. That would give us an x equals 5, x equals negative 5 is 0. X minus 2 equals 0. That would give us x equals positive 2. X equals positive 3. And then what we're going to do now is we set x squared plus 1 equals 0. Here's the issue. I start solving this. X squared equals negative 1. Alright? Okay? It's the square root. X is going to equal, now in this case, you can't take the square root of negative numbers. However, with imaginary numbers, we know that that I squared is negative 1, and the square root of negative 1 is I. So we get x is equal to plus or minus I. Okay? So, those are our imaginary zeros. Plus or minus I. Plus positive I and negative I. So, what we do is we take all that. Okay? We are going to write this whole thing as linear factors. We have x plus 5 times x minus 2 times x minus 3 times x plus I times x minus I. And that, yeah, at that point, you're done. All right. So, who's that? All right. So here's the deal. So here's what's going on. All right. Let's see what I've got. Alright, let's look at this problem. Alright. Focus. You're right.
What a dying breath. Baby got like really upset.
Alright. So this problem's a lot like the one we just did. Alright? Except in this case, instead of me giving you positive zeros or no zeros, I'm giving you the fact that we know that 2 minus 3i is a 0. So we know that there's at least one complex real zero. Alright? So, the first thing that, what's the first thing you guys want to do? Sign changes? Alright. Now, I'm not going to rewrite this here, but, okay, so there's one sign change, two sign changes, three sign changes, no sign change. That means that there is 3, 4, 1 positive.
What you need to do is writing them down and make sure that everyone should do it.
Okay. Now we have p of negative x, x to the 4, plus 6x cubed, plus 20x squared, plus 22x, minus 13. There's one sign change here. That tells us that there's one negative real zero. Alright. So, what do you guys want to do? You guys want to do what? Huh? Factor what? Nice. What factor? What factor negative 13?
Rational zero.
Rational zero theorem. Plus minus 1 plus minus 13. I'm a factor positive 1 plus minus 1. Right, so there's only 4 possible choices. But I'm already given a 0. Alright? So I know that my potential possible rational zeros are plus or minus 1, plus or minus 2. Okay, cool. Now, I'm not even going to start with those. I'm already given, because why start with those when I know that I'm gonna have to guess. Okay, it's just gonna be a guessing game, trying to choose one I want to know. Why do that when I already have one that I know? So, I know 2 minus 3i. I know this is 0. Okay? And I know my coefficients are 1, negative 6, 20, negative 22, negative 13. Okay? Now, I'm just doing what I typically do. 1. Okay? 2 minus 3i times 1 is going to be 2 minus 3i. Right? So, negative 6 plus 2 is going to be negative 4. And then I'm going to have minus 3i. Right? Okay, so now, guys, this is we can find avoid this, but this is good practice. So now I'm going to do 2 minus 3i times negative 4 minus 3i. So it's going to be 2 minus 3i times negative 4 minus 3i. So 2 times 4 is 8. 2 times negative 3 is negative 6i. Negative 3i times negative 4 is positive 12i. So I have negative 6i plus 12i. That's going to be plus 6i. And I'm going to do negative 3i times negative 3i. Negative 3 times negative 3 is positive 9. I times I is negative 1. 9 times negative 1 is negative 9. So this is equal to 8 minus 9 is negative 1 plus 6i. So, 1 plus 6i. 20 plus negative 1 is 19. and then plus 6 I. Huh? Oh, that is negative. Negative 17. Negative 17 plus 6 I. That's going to be 3 times 3 plus 6 I. I got 9, negative 3 I times negative 3 I is negative. Let's go check. 2 times negative 4 is negative 8. 2 times negative 3i, negative 6i. Negative 3 times negative 3i times negative 4b, positive 12i, which is positive 6i. Negative 6i plus 12i is.
Oh, okay, all
Right? So now I'm going to do 2 minus 3i times 3 plus 6i. 2 minus 3i.
Oh, that. Oh, that's something wrong with it. No, it's not.
Oh, second.
Because they gave you a 0.
Yeah, negative 0. 2 times 3 is 6. 2 times 6i is 12i. Negative 3i times 3 is negative 9i, so it's 12i. Plus negative 9i, that's going to be plus 3i. And negative 3i times 6i is going to be negative 18 times negative 1 is 18. So it's 24 plus 3i. 24 plus 3i. Negative 22 plus 24 is 2 plus 3i. That's cool. Because now I see 2 minus 3i, 2 plus 3i, those are what? Also. Conjugates. So that means all the i's are going to go away. Okay? So it's going to be, what? So we're going to have 2 minus 3i times 2 plus 3i. That's going to be 4. 2 times 3i is 6i. Negative 3i times 2 is negative 6i. Those cancel out. Negative 3 times 3 is negative 9 times I squared is negative 1. So negative 9 times negative 1 is positive 9. 13. 13. Negative 13 plus 13 is 0. That tells us 2 minus 3i is a 0.
So those are nice things to do.
Yeah, so the next thing we're going to do is we have, so we know 2 minus 3i is a 0. What else do we know is a 0? Pairs. What's the conjugate of 2 minus 3i? And that tells me, and I know 2 plus 3i has to be a 0. So then I have 1. I have negative 4 minus 3i. I have 3 plus 6i. And I have 2 plus 3i. It is not the 0. There's a 1 down. That's going to be a 1. That's 2 plus 3i. Negative 4 plus 2 is negative 2. Negative 3i plus 3i is 0. It's gone.
Yes. Oh, that line's still there, though.
2 plus 3i times negative 2. So 2 times negative 2, that's going to be negative 4. 3i times negative 2, that's going to be negative 6i. Negative 3 plus negative, or 3 plus negative 4 is going to be negative 1. 6i plus negative 6i is going to be there. Then 2 times negative 1 is negative 2. 3i times negative 1 is negative 3i. That cancels out. 0. I is gone.
Ooh, my brain.
So,
The number of eyes?
2 2 minus 3i, 2 plus 3i, those are two zeros. Okay? Now, here's the nice thing. Starting with x to the fourth, right? So this would be x cubed, that would be x squared. So now, we have x squared minus 2x minus 1. Right? Now, here's my thing. That right there, is that factorable or not factorable? Factorable? Alright. So, if we were to graph this, y equals x to the fourth. Minus 6x to the third. Squared. Dang it. You got this. Uh-oh. Those don't look like nice zeros.
Why are they crooked? It's not even, bruh.
That's between 0 and 1, that's between 2 and 3. And unfortunately for us, what's happening right now is we don't have numbers between 0, 1, 2, and 3. We have no fraction. So that means that this is not factorable. But I want to know the zeros.
You have to put an eye?
No I.
I'm scared.
Who said it's scary? This is like algebra 2 right now.
I didn't know. Right, man. Algebra 2. Actually, you know, that formula.
Quadratic formula. Everyone's out. Everyone's out.
I always forget that.
You didn't have to do that. X equals the opposite of b, which would be positive 2.
I hadn't even.
Plus or minus the square root. I hope we're paying attention. Seems like you're on homework like this. B squared, that's going to be negative 2 squared, that's 4. Right? Minus 4 times a, which is 1 times c, which is negative 1. Alright? Divided by 2 times 1. We get 2 plus or minus the square root of 8 divided by 2. So that tells me. Alright, now another thing I can do is 2 plus or minus the square root of 4 times 2 divided by 2. So that's equal to 2 plus or minus, what's the square root of 4? 2, so I can pull that out. Square root of 4 is 2, square root of 2 divided by 2. I will say, if you left me with this answer, I would accept it. But right here, the 2's all canceled out, so I'm left with 1 plus or minus square root of 2. So my zeros of this polynomial are 1 plus the square root of 2, 1 minus the square root of 2, 2 plus 3i, 2 minus 3i, alright? And then I'm done. Those are my zeros. Questions? Now,
their homework.